and welcome to our SHAM course on Power Generation Technologies. My name is Kundan Sahu, lecturer in Mechanical Department from Uday Prasad Uday, Government Polytechnic, Durg. I am here to teach Module 4 of Power Generation Technologies. In my previous video lecture, we have discussed about classification and types of nuclear power plant. So let's quick review of previous video lecture about types of reactor as shown in table. In this table, neutron energy is thermal type, and first reactor type is pressurized water reactor. Coolant is used H2O, moderator is used H2O, and fuel enrichment is low uranium oxide. Second type is neutron energy type is thermal energy type, and reactor type is boiling water reactor. Coolant is also used H2O, moderator is used H2O, fuel enrichment is low uranium oxide. Third type is neutron energy, this is a thermal type, and reactor type is gas cooled reactor. Coolants are used carbon dioxide and helium. Moderator is graphite, fuel enrichment is low uranium carbide. Next, neutron energy is a thermal energy, same. Reactor type is heavy water reactor, that is CANDU type, we have discussed in previous video lecture. Coolant is D2O, that is deuterium. Moderator is also D2O, and fuel enrichment is natural uranium oxide. Next, neutron energy is fast. Reactor type is liquid metal fast breeder reactor. Coolant is sodium. There is no moderator is used. Fuel enrichment is plutonium 239, oxygen, and uranium 238 and oxygen. And next, neutron energy is same, fast neutron energy. Reactor type is gas cooled fast reactor. Coolant is helium. Here also no moderator is used. Fuel enrichments are plutonium 239, oxygen, plus uranium 238 and oxygen. So this is the quick review of our previous video lecture. With the help of this table, you can solve different multiple choice question very easy. So let's move in next slide. In this video lecture, we will discuss about site selection and comparison of nuclear plants with thermal power plants. Selecting the site for a nuclear power plant is a complex and highly regulated process that involves careful consideration of numerous factors to ensure safety, security, and efficiency of the facility. Here are the key steps and factors involved in site selection for a nuclear power plant. Different factors involved, these are as following as geological stability, water availability, distance from load center, distance from populated area, transportation facilities, radioactive waste disposal facility, security and defense, nature of land, environmental impact assessment, that is EIA, population density and sitting distance, emergency preparedness and response, regulatory requirements, technical feasibility, public acceptance, availability of skilled workforce, grid connection, cooling consideration, economic factors. So let's discuss about first site selection factor is geological stability. The site must be geologically stable to minimize the risk of earthquakes, landslides, or other natural disasters that could damage the facility. Seismic activity, fault lines, and soil stability are all important consideration. Second site selection factor is water availability. Inside the reactor of the nuclear power plant, water is used as a moderator for cooling the heat generated by fission reaction and for other cooling purposes also. So the requirement of the water in nuclear power plant is very high, that is twice the requirement of water in thermal power plants. So the plant must be located in the area where availability of water is plenty, that is near the river, lake, or by the seaside. Next factor is distance from load center. The power plant should be located near the load center, as this will reduce the cost of transmission line and also reduces the transmission losses. Hence, practically a power plant should always be located near the load center, but we cannot place nuclear power plant that closest to the load center. So for this, authorities have to erect a nuclear power plant by taking all safety consideration and other requirements like reasonable land cost, adequate cooling water, away from population distribution, local zone restriction, accessibility for fuel shipment, etc. Next site selection factor is distance from populated area. As we know that for fuel we use for the nuclear power plant is radioactive material like uranium, thorium, etc. And though we take all the safety measure, we cannot make all the environment around the power plant radioactive free. So there should be a reasonable distance between the nuclear power plant and nearest populated area from the safety point of view. However, as a precautionary measure, a dome structure is used in the plant which does not allow radioactive to spread through underground waterways or wind. Also, it is highly undesirable to choose a site adjacent to the chemical industry, oil refineries, hospitals or schools. So, the power plant must be located away from a populated area. Next factor is transportation facilities. We have studied in a steam power plant that we need railway lines to transfer the tons of coal. Still, in the case of nuclear power plants, the fuel requirement is very less. Hence, we require the transportation facility during the nuclear power plant construction only. In contrast, we may not require all the transportation facilities like steam power plants for normal working days. So, the site should be accessible by rail and road as heavy machinery are to be brought to the site during the installation and fuel during its operation. Next factor is radioactive waste disposal facility. Like the other power plants, we cannot dispose of the wastage of nuclear power plant. After all, the use of fuel to generate electricity, even after decaying the fuel, it still remains radioactive and hazardous for us. The waste of a nuclear power plant are very radioactive, therefore sufficient space must be there to dispose the radioactive waste. Next factor is nature of land. The land should have good bearing capacity of about 1 meganewton per meter square and must not come under earthquake prone zone. The land is studied for its past history of tremors and earthquake in order to design the plant that can withstand the severest earthquake. While selecting the site for nuclear power plant, one should select the land having high sustainability to withstand all the burdens of reactor and other heavy types of machinery. The goal is to ensure that the site can withstand potential earthquakes and other geological hazards. Next factor is environmental impact assessment, that is also known as EIA. Perform an environmental impact assessment to identify and assess potential environment impacts of the facility. This includes evaluating the impact on local ecosystems, air, water quality and wildlife habitats. Mitigation measures should be proposed to minimize adverse effects. Next factor is population density and sitting distance. Analyze the population density in the vicinity of proposed site and determine appropriate sitting distance to minimize the potential impact on nearby communities in case of an accident. Regulatory agencies often establish specific safety zones. Next factor is security and defense. Evaluate the security and defense aspects of the site. Consider the site's vulnerability to external threats, terrorist attacks and potential sabotage. Security measures should be incorporated into the design. Emergency preparedness and response. Develop detailed emergency preparedness and response plans in coordination with local authorities. These plans should cover accident scenarios, evacuation procedures, and communication protocols. Next factor is regulatory requirements. Begin by understanding the regulatory framework and requirements for nuclear power plants in the country or region where the facility is planned. These regulations are typically established by government agencies responsible for nuclear safety and environmental protection. Next factor is technical feasibility. Assess the technical feasibility of the site for hosting a nuclear reactor. This includes soil stability assessments, groundwater conditions, and geotechnical studies to ensure the site can support the facilities infrastructure. Next factor is public acceptance. Gauge public acceptance and support for the construction of a nuclear power plant in the chosen location. Public opinion can significantly impact the approval process and ongoing operations. Next factor is availability of skilled workforce. Consider the availability of skilled workforce in the region for both construction and operation of the nuclear power plant. Next factor is grid connection. The site should have access to the electrical grid to distribute the generated power. Proximity to existing electrical infrastructure can reduce costs. Next factor is cooling considerations. In addition to proximity to water sources, the site must consider cooling methods, including whether ones through cooling or cooling towers are more appropriate. Next factor is economic factors. Assess the economic impact of the nuclear power plant on the local and regional economy, including job creation and tax revenue generation. So, site selection for a nuclear power plant reactor is meticulous and highly regulated process that prioritizes safety and environmental protection. It involves collaboration between government agencies, nuclear experts, and the local community to ensure the responsible and safe operation of the facility throughout its lifespan. Next point is comparison with thermal power plant. Nuclear power plants and thermal power plants, often fueled by fossil fuels like coal, natural gas or oil, are both sources of electricity generation, but they operate on different principles and have various advantages and disadvantages. Here's a comparison of these two types of power plants. Different comparison factors is there, which are as following as fuel source, greenhouse gas emissions, energy efficiency, energy security, safety and environmental concerns, radioactive waste, cost, site running cost, limit of source of power, cleanliness and simplicity, overall efficiency, starting space required, maintenance cost, standby losses, cost of fuel transportation, reliability, operational lifespan, resource dependence, renewable integration. So, given figure from the basic difference between thermal power plants and nuclear power plants. You can see in given figure, the main component in thermal power plant is boiler and main component in nuclear power plant is nuclear reactor. Inside the nuclear reactor, nuclear fission occurs. So, the basic difference between nuclear power plants and thermal power plant is that nuclear power plants use nuclear fission inside the nuclear reactor to produce electricity, while thermal power plants use heat with the help of boiler to produce electricity. Other components like turbine, generator, condenser, cooling tower and pump occur in both nuclear and thermal power plants. Nuclear power plants are more expensive to build than thermal power plants. Nuclear power plants are more difficult to decide than thermal power plants because of the fear of nuclear accidents. First comparison point is fuel source. Nuclear power plants use nuclear reactions typically involving uranium or plutonium as their fuel source. These reactions release a large amount of energy, that is heat, through nuclear fission. The heat is used to produce steam, which drives turbines to generate electricity. In thermal power plants, primarily use fossil fuels like coal, natural gas or oil as their fuel source. They burn these fuels to generate heat and produce steam to turn turbines and generate electricity. Second comparison is greenhouse gas emissions. Nuclear power plants produce electricity with virtually no direct greenhouse gas emissions during operation. However, there are emissions associated with mining and processing nuclear fuel and managing radioactive waste. In thermal power plants, release significant greenhouse gases, particularly carbon dioxide, when they burn fossil fuels. This makes them a major contributor to global warming and air pollution. Next comparison is energy efficiency. Nuclear power plants are highly efficient and have a high energy density. They can produce a large amount of electricity from a relatively small amount of fuel. In thermal power plants, these are less efficient than nuclear power plants because substantial portion of the energy in the fuel is lost as waste heat during combustion. Next comparison is energy security. Nuclear power plant can provide a stable and consistent source of electricity since fuel availability is not subject to price fluctuations or supply interruptions like fossil fuels, and the thermal power plants can be affected by fluctuations in fossil fuel prices and supply disruptions, which can lead to price volatility and energy security concerns. Next comparison is safety environmental concerns. Nuclear power plants have complex safety and environmental concerns, including the risk of nuclear accidents, the long-term storage of radioactive waste, and concerns about nuclear weapons proliferation. And the thermal power plants have environmental concerns related to air and water pollution, including the release of pollutants like sulfur dioxide, nitrogen oxide and particulate matter. Next comparison is radioactive waste. Nuclear power plants produce radioactive waste which requires long-term storage and management. Finding suitable disposal solution is a major challenge, and the thermal power plants produce solid waste, that is ash and air emissions, but these are generally easier to manage compared to radioactive waste. Next comparison is cost. In nuclear power plants, the construction and decommissioning of nuclear power plants can be expensive, and the industry often faces cost overruns and delays. In thermal power plants, the construction of thermal power plants is generally less expensive than nuclear plants, but ongoing fuel costs can vary significantly. Next comparison is site. Nuclear plants are located away from thickly populated areas to avoid radioactive pollution, and in thermal power plants, these are located at a place where ample supply of water and coal is available. Transportation facilities are adequate. Next comparison is running cost. In nuclear power plant, running cost is small because a small amount of fuel can produce relatively large amount of power, and in thermal power plant, running cost is higher than nuclear plants because of the requirements of huge amount of coal. Next comparison is limit of source of power. In nuclear power plant, the source of power is the nuclear fuel which is available in sufficient quantity. It is because a small amount of fuel can produce huge power. and in thermal power plant, coal is the source of power which has limited reserves all over the world. Next comparison is cleanliness and simplicity. Nuclear power plant is more cleaner than thermal power plant, and thermal power plant is less clean as atmosphere is polluted due to coal smoke. Next comparison is overall efficiency. In nuclear power plant, it has more efficient than steam power station, that is approx 55%, and thermal power plant is less efficient as compared to nuclear power plant, that is about 25%. Next comparison is starting. Nuclear power plant can be started easily and thermal power plant requires a lot of time for starting. Next comparison is space required. Nuclear power plant require a minimum space as compared to thermal power plant of equivalent capacity, and thermal power plant needs sufficient space because of boiler and other auxiliaries. Next comparison is maintenance cost. In nuclear power plant, very high trained person are required to handle the plant, and in thermal power plant, quite high as skilled operating staff is required. Next comparison is standby losses. Nuclear power plant has less standby losses, and in thermal power plant, standby losses are maximum as boiler remains in operation even when the turbine is not working. Next comparison is cost of fuel transportation. In nuclear power plant, cost of fuel transportation is minimum because a small quantity of fuel is required, and in thermal power plant, cost of fuel transportation is maximum because huge amount of coal is transported to the plant site. Next comparison is reliability. Nuclear plants are known for their high reliability and consistent power output, and the reliability of thermal plants can be affected by fuel supply issues, equipment failures, and environmental regulations. Next comparison is operational lifespan. Nuclear plants can have long operational lifespans, often exceeding 40 years with the possibility of extensions, and the operational lifespan of thermal plants can vary, but they generally have a shorter lifespan due to wear and tear on the equipment and environmental concerns. Next comparison is resource dependence. Nuclear power is not dependent on fluctuations in fuel prices, making it more stable in terms of energy cost, and thermal power generation is influenced by the price and availability of fossil fuels, making it susceptible to price volatility. Next comparison is renewable integration. Nuclear power provides base load electricity and is less flexible in responding to changes in demand compared to some renewable sources like wind and solar. And in thermal power plant, it can be more easily ramped up or down to match demand, but still produce emissions. So in conclusion, the process of selecting a suitable site for nuclear power plant is complex and highly regulated endeavor. We have discussed the key factors that influence site selection, including geological stability, proximity to water sources, population density, and regulatory considerations. It is crucial to emphasize that the safety and security of a nuclear power plant heavily depend on the careful evaluation and selection of an appropriate site. Now, let's take a moment to compare nuclear power plants with thermal power plants, particularly those using fossil fuels like coal or natural gas. While both types of power plants generate electricity, there are significant differences to consider. Firstly, nuclear power plants produce electricity without emitting greenhouse gases, making them a cleaner option in terms of environmental impact compared to the thermal power plants. This is especially relevant in our efforts to combat climate change. And secondly, nuclear power plants provide a more consistent and reliable source of energy, as they are not dependent on fuel supply chains susceptible to disruptions or price fluctuations. Thermal power plants, on the other hand, can be affected by fluctuations in fuel availability and prices. However, it is important to acknowledge that nuclear power plants come with their unique challenges, including nuclear waste management, decommissioning, and safety concerns. Thermal power plants, while producing greenhouse gas emissions, do not carry the same risk associated with nuclear accidents. In the end, the choice between the nuclear and thermal power plants depends on a country's energy needs, environmental goals, and risk tolerance. Both technologies have their merits and drawbacks, and a balanced energy portfolio may involve a mix of both. As we navigate the complex landscape of energy production, it is essential to weigh the pros and cons carefully, taking into account the long-term consequences of our choices. Site selection for any power plant, be it nuclear or thermal, must prioritize the safety of communities and the protection of the environment. Thank you for your attention. We hope this video session has provided valuable insights into the considerations surrounding nuclear power plant site selection and its comparison with thermal power plants. If you have any further questions, please feel free to ask.